Now we're going to be talking about the Poisson or Poisson distribution. So the Poisson distribution is used in scenarios when you want to figure out like what's the chance of something happening within a specific unit of time. So a good example would be, oh my God, 2 people have just come in with appendicitis in the last hour. What are the chances of that happening? And if you know how often people come in with appendicitis, on average, you can calculate what the chance would be that they come in such close proximity to each other. The example we're going to use is about Rift Valley fever in South Africa. So we're going to use the Poisson distribution, and let's get down some of these numbers. And for this one particularly, because it's got a couple of steps to it, it's particularly important that we list the information that we have and label it correctly. So let's go like this. So the number of outbreaks that we have in that time, unit time is 6. How many years? Well, that's 35. So how many outbreaks per year? So we're looking for a mean here, aren't we? So let's go 6 divided by 35. So that's our mean. Now, the question is, what would be a conservative estimate of how many outbreaks could occur in the next 10 years? So what we can do here, there's potentially 2 years we could do it. One, we could keep it as a year, like just per single year, or we could make it per, like the mean per 10 years. So let's go out. So outbreaks per 10 years, and you just want to multiply by 10. By 10, whoops. Cool. Yep. Sweet. So what are the chances that we have? So let's put our numbers in here. So we're looking for number of outbreaks, right? And this is the probability of that happening. So as always, a bit of brute force / just chucking the numbers in. So let's go up to 10 outbreaks. So we use the Poisson distribution, so equals Poisson tab x. So what the chances of 0 outbreaks happening in the next 10 years. So we do like this, ping, and the mean, because we're looking for a unit of 10 years, we would do that. And let's make it cumulative for now. So the chance of there being 0 outbreaks in the next 10 years is about 18%, so not bad. But if you had to put your money on one number, I don't know why that's being, oh, I see. All right, I was a bit silly. All right, go back here. I forgot to put in the thing that tells Excel to keep it on that particular cell. Let's try that again. That's better. QL, 30%. But if you had to pick one number, you couldn't, it's not as easy to look at it like this. But let's plot it on a graph. Oh, no, you know what, I'll just show you. So Poisson, this number, mean is that number, and we don't want it to be cumulative this time. This time I won't forget to put those dollar signs in to keep that cell the same. Can't see. Where's that there now? So if you had to pick one number for how many outbreaks are going to be in the next 10 years, you'd probably put your money on 1, because that has the highest single percentage. So this has got an 18% chance of there being no outbreaks, 30% chance of there being 1 outbreak, 26% chance of there being 2 outbreaks, 15% 3, and so on. But for now, let's chuck this in a chart. So insert. You can use histograms for that as well, except I don't like it because it sort of can look a bit messy like that, and you've got to fiddle with the labels and things. I prefer scattergrams or scattergraphs. So as you can see, these graphs do look a little bit different compared to the other graphs. So as always, let's put our axes on. That just helps us understand it a bit more. This is probability, and this is outbreaks. You can't see that out. Well, there's so many things that get in the way. It's really annoying. Probability of Rift Valley fever outbreak in next 10 years, and remember to label it correctly. So for the Poisson, we have a specific way of labeling it. We want to put the T on beta, which for the time is 1, but we just put what our outbreak is, so like that number. So 1.74. You could go on. Okay. All right. Cool. And if we wanted to chuck these other ones on as well, that can make it look a bit more appealing. So let's look series of Y values, these bad boys, X values. I find this is always quite fiddly. You've got to sort of go back if you don't select all the data at the same to start with. And this one might be better done as a block, perhaps, like a histogram type one, but whatever. So you can see the single number of outbreaks with the highest probability is 1, as we expected from here. Great, so that is doing a Poisson distribution. A few extra steps in there with the number of outbreaks per 10 years when you're trying to measure in 10 years, as opposed to just 1 year. So that's why it's really important to keep that that information clear and label it correctly, because then you can answer the question that they ask you. Any questions, as always, comment in the box.